Section B, the principle of conservation of linear momentum.
Now for some fun stuff. We're going to talk about collisions. Things knocking into each other.
When two particles collide, the momentum of the whole system, that is, of what happens before, during, and after the collision, is the same before and after the collision. This is called the principle of the conservation of linear momentum.
Before we go on to explain the conservation of linear momentum, recognize that we will talk in terms of particles, because large objects and particles, like atoms and molecules, are both affected by this principle.
The principle of conservation of momentum says that the final momentum of the system equals the initial momentum of the system. Since P equals mv, if two particles collide, the mass of the first particle times its velocity before the collision plus the product of the mass and velocity of the second particle before the collision equals mass times velocity of the first particle after the collision plus the mass times velocity of the second particle after the collision, or m1 times v1 before plus m2 times v2 before equals m1 times v1 after plus m2 times v2 after. And the total linear momentum after minus the total linear momentum before is always zero. And that can be written as the change in momentum, delta p, equals 0.
The momentum after is the sum of the particles' momentum after the collision, or p after equals p sub 1 after plus p sub 2 after. And the momentum before is the sum of the particles' momentum before the collision. So, when we take the difference between these two, we get p after minus p before equals the quantity p sub 1 plus p sub 2 after minus the quantity p sub 1 plus p sub 2 before.
Okay, so we saw that the principle of conservation of linear momentum says that the final linear momentum equals the initial linear momentum, or delta p equals p after minus p before equals 0. If delta p equals 0, then delta p1 plus delta p2 also must always equal 0.
And if the linear momentum of particle 1 increases, then the linear momentum of particle 2 must decrease by exactly the same amount. That is, delta p2 equals negative delta p1.